Hello and welcome to our lesson on average rate of change. Rate of change is hopefully something that you've heard of before. You see it or you talk about it a lot with linear functions. Rate of change is fancy talk for slope. Okay, and what slope is describing how one quantity changes in relation to another. So the rate of change just describes how one quantity changes in relation to another. So specifically, or I guess we could say generally, if we don't have any context to tell us what the two quantities are, if we just say here's a function with x's and y's, our rate of change would be describing how the y values are changing, with respect to the x values. Okay, for a linear function, again, this is where we probably have seen this before. For a linear function, the rate of change is just called slope. And we could still call it slope for what we're looking at here, the nonlinear functions. But what's special about the linear functions is that the slope, or that rate of change from one point to any other point on the graph, it's going to be constant. The slope is constant. That means it changes at the same rate. The y values change with this, in relation to the x values at the same rate from any one point to any other point. Okay, so let me just show you an example. We've got a linear function graphed here, in fact, the parent linear function. So if I started at the origin here, and I wanted to, it's not the parent. If I wanted to get to the next point, I would have to, from this point at the origin to the next point that I chose, I would have to rise 2 and run 1. So we would say that the slope here is a rise over run. Rise 2, run 1 would be 2 over 1, or just 2. Okay, now from the point I left off to the very next point, it's the same thing. Rise 2, run 1, right? Or if I go in reverse, right, go to the next point here, working in reverse, same rise, same run, from any point to another. Now, if I jumped, okay, let's say I started at this point and jumped to this one, then it would be a rise of 4 and a run of 2, but that still reduces to the same 2 over 1. So no matter what 2 points I pick on a linear function, I'm going to end up with the same ratio of rise to run. It's a constant slope no matter what. Now if you're looking at a function that isn't linear, so for other functions, non-linear functions, then the rate of change isn't constant. Okay, so let's jump over here to this parabola. Let me start at the origin here. To get to the next point, moving to the left, I would have to rise 1 and run 1. So between those 2 points, my slope would be 1 over 1, or just 1. Now, where I left off to the next point, I would have to rise 3 and run 1 to get to the next point. So the rate between the 2 points there, or the rate at which we rise and run, has changed. And again, to get from the point I left out to the very next point, now I'd have to rise 5 and run 1. So the slope there would be 5 over 1. And if I go to the other side of the parabola, let's say I wanted to go from this point to this point, well, now I would have to go down 5 and right 1, which means this slope would be a negative 5 over 1. So depending on what portion of the graph I'm looking at, the slope could change. And if I wanted to jump, let's say from the origin here all the way to this point here, then we would be rising 9. We would be rising 9 and running 3. So we would say that the average slope over that giant interval would be 3 over 1, or 3. Okay, so we're going to calculate slope as rise or run, or the change in y's with respect to the change in the x's, the same way we would calculate slope on a linear function. But when we calculate it on something that's not linear, it's called an average slope. So the average slope over the interval in the pink there is 3. That doesn't mean the slope is 3 all the way across. We saw here it was 1, here it was 3, here it was 5. That 3 just represents what's the average slope over that entire interval, right? And in fact, if I average 5 and 3 and 1, I get 3. Okay, so we're calculating slope the same way. Rate of change still represents slope. It's just average for an average of slopes over intervals for functions that are not linear. Okay, so this is going to be called an average slope. Okay, but again, calculations are the same, so hopefully this little formula looks familiar to you. So again, your rate of change, or average rate of change, is just slope. It represents how the y values are changing with respect to the x values. So this little delta here, that's the symbol for delta. It means the change in. Okay, so it's the change in the y values with respect to the change in the x values. Okay, so if we wanted to know the change in the y values or the change in the x values, I showed you in the last two examples you could just count, but that isn't always efficient because you don't always have a graph, and maybe you have points that you're looking at that are really far away. So how do we technically calculate the change in y values or the change in x values? Think about really simply here, okay? If you were starting at a y value of 2 and you ended up with a y value of 6, right? If you started at 2 and you landed at 6, that's a change of 4. Well, the way to get to that change of 4 units is to subtract, right? 6 minus the 2 would get you to that 4. And it works the same way on the x-axis, or with the x values. So if we want to calculate the change in the x's or the change in the y's, we're just subtracting. Now, I put the formula here how you would standardly see it, which is take the second y value, subtract the first, take the second x value, subtract the first. Although that doesn't really matter, you could also take the first y value and subtract the second. But if you're going to take the first y value on the top of the fraction, then make sure you take the first x value on the bottom. So as long as you're consistent with the order, it doesn't really matter which way you go there. Okay? So hopefully that looks familiar. So we're just calculating slope. We are just subtracting two y values, subtracting two x values, and then leaving as a reduced fraction if it doesn't divide to a whole number. Okay, so simplifying that fraction if possible. So the tricky part is, how do I identify the two x's and two y's that we're going to be calculating the slope for? If you look at example 1, it says find the average rate of change for this function, and hopefully you're looking at that function having an idea of what kind of function it is. It's a square root function, okay, that little hill shape. Technically, we have forever in this direction, we have an endpoint here. It's just copying these things out of Desmos, and I can't capture those arrows all the time. Okay, so if we want to find the average rate of change for this function, we have to know where we're looking on this function. So what we're given here is an interval of where to look, and that interval is an interval of x values, right? Intervals, remember, for increasing, decreasing, positive, negative, and here they're always x values. What's the x value where it starts and the x value where it stops? So in this interval, we are looking at an x value and an x value, like x1 and x2. So this is an interval, again, of x values. This is saying, look at this graph from -2 to +6. That is the interval we are looking at. So what I want is the starting point of the graph on that interval and the ending point of the graph on that interval. So the starting point happens to be here, and the ending point happens to be, oh, that's 5, just kidding. The ending point happens to be here. So this is a coordinate. The first x value of -2 corresponds with the y value of 0. And here's our second coordinate. Our second x value of 6 corresponds with a y value of 2. Okay, so now we have our 2 points, and now we can calculate the average slope over that interval. So our slope now is going to be y2 minus y1, which is 2 minus 0, over x2 minus x1, that's 6 minus a -2. So 2 minus 0 on the top is 2. On the bottom, the double negative there becomes a positive, and 6 plus 2 is going to make 8. And then 2 over 8 reduces to 1/4. So the average slope over that interval is 1/4. Okay, so now just so you can see this again, that doesn't mean if I rise 1 and run 4 from one point to the next, it's going to land exactly. So if I start here and I rise 1 and I run 1, 2, 3, 4, I don't land on the next point. But if I do it again, rise 1 and run 1, 2, 3, 4, I do end up at the end point. So that slope of 1/4 is an average over that interval. Okay, hopefully that makes some sense. Okay, let's try it again. So this one is, maybe you recognize, looks like a cubic function. We want to find the average rate of change over the interval from 0 to 3. So 0 to 3, that's the starting x and ending x. Okay, this is your x1, and x2. So I just want to find the endpoints of the graph over that interval. So here's the first point. It happens to be on the x-axis there. And then the second one is here. So we are starting at an x value of 0 corresponding with a y value of 0, and then our ending x value of 3 corresponds with a y value of -8. And so now we can calculate our slope. So we have y2 minus y1, -8 minus 0, x2 minus x1, 3 minus 0, and that's going to be a -8 on the top of the fraction and +3 on the bottom. And so that's it, a -8/3. And then just, to give you a general picture here, we should have known in the first example, because the graph was increasing, that we would get a positive slope. And we should have known looking at the second example, because over that interval the graph is decreasing, that we would have had a negative slope. So positive slope for increasing graphs, negative slope for decreasing graphs. Okay, or intervals. All right, let's try it again. Here we have a quadratic function that is reflected and shifted, but still a quadratic. Says find the average rate of change over the interval from -2 to 2. So -2 to 2 on the x-axis, that's that interval right there. So our starting point is at -2, 0, and our ending point is at 2, 0. And the slope, hopefully we can see what's going to happen. If you calculate y2 minus y1, 0 minus 0, and then x2 minus x1, 2 minus a -2, we end up with 0 over, that's a plus, so 4. That's a slope of 0. And that should make sense. I mean, look at where those endpoints line up, and think about what's happening on the graph here. Here we have a increasing section, and here we have a decreasing section, and we can see that those are symmetric, perfectly symmetric, which means that the positive that's on this side and the negative that's on this side would have to cancel each other out. Okay, so if you saw that and you didn't want to make the calculation, you'd be totally okay just saying, oh, that's going to be a slope of 0. Okay? Here's one for you to try. If you're feeling pretty confident with this, feel free to pause the video and give it a shot. So this says, find the average rate of change over the interval from -1 to +1. So on my x-axis, which is way down here, -1 to +1, that's that interval. So that corresponds with an endpoint here and an endpoint here. So here is -1 and +8, and then here we are at +1 and 0. So our slope is going to be y2 minus y1, that's 0 minus 8, and then x2 minus x1 is 1 minus a -1. So that's going to be a -8 over, this becomes 2, and -8 divided by +2 makes a -4, or -4 over 1 for our average slope. Okay, so same concept in the next few examples, but what you're going to notice is that we're given different information. So instead of a picture for a square root function, or a picture for a rational function, or a picture for a quadratic function, we're given the equation for the function. So we've got some options. If we wanted to graph that function and highlight the interval and see the endpoints on that interval, just like we did on the previous examples, we absolutely could. But if we actually have the equation for the function, we can take another approach. So this interval is still an interval of x's. If I know the first x value and the second x value, what could I do to find the y values that correspond with those x values? Well, if you were trying to graph this function and you were making a table of values and you knew the first x value you wanted to plug in was 4, or the first x value you wanted to plug in to find the other half of the coordinate for you, you'd plug it in, right? If you plug in the 4, you're going to find the y value that goes with it. If you plug in the 13, you're going to find the y value that goes with that. Okay? So you're trying to find the other half of the coordinate. It'd be like making a table of values to graph. So I think that's a good way to organize this. If we have x and f of x, since it's not called y here, they're giving us the two x values, saying we have an x value of 4 and an x value of 13. We just have to find the y values that go with those, so we have the 2 points that we need to calculate our average slope. So if I find f of 4, and that's what the function, or that's what the additional part of this formula up here says. If I plug the second x value into the function, I'll get the function value, right? I'll get the y value that goes with it. If I plug the other x value in, same concept. So this it looks kind of fancy, and you're going to see this as you move on to higher levels of math. So if you go to calculus, they call this something fancy. It's called the difference quotient. Difference means you're subtracting. Quotient means you're dividing what you've subtracted there. It's again, you're going to see it in calculus as you move on. So, but just maybe if you can make a mental note when you hear that difference quotient, it's just slope. Okay. So let's find f of 4. If I plug the 4 in, f of 4 is going to be the square root of 4 minus 4. That is the square root of 0, which is 0. So there's our first y value. And let's find f of 13. I plug 13 in. Square root of 13 minus 4 is the square root of 9, and that's going to be 3. Okay, so that's half the battle. That's picking out the two endpoints like we just did on the graphs above. Okay, so now we have our two coordinates. Now we're going to calculate our slope. So slope is going to be y2, or let's say y2 minus y1, so 3 minus 0. And then x2 minus x1 is going to be 13 minus 4. So we have 3 over 9, or 1/3 when we reduce. Okay, so a slope of 1/3 here. Okay, let's try that again. We want to find the average rate of change for this time a rational function, and the interval we're looking at is from 3 to 10. So we have x, and we have h of x this time. And we know we need to plug in 3 and we need to plug in 10. So let's find h of 3. If I plug 3 into the function, 1 over 3 minus 2, well, that's 1 over 1, which is just 1. So we have our first coordinate. Now let's find h of 10. Okay, h of 10 is going to be 1 over 10 minus 2, so 1/8. 1/8 here. Okay, so not pretty, but they're not always going to be nice whole numbers or nice reducible fractions. But we have enough information now to find our slope. So y2 minus y1 is 1/8 minus 1 in the top of the fraction, and then x2 minus x1, so 10 minus 3 in the bottom. Now this is absolutely arithmetic that you should be able to do, but I'm just going to tell you, I wouldn't do it myself. I don't want to risk making any silly mistakes, so I'm going to go ahead and go to my calculator. Desmos is really nice, okay? I'm going to hit the fraction button to give me, or hit the divide button, excuse me, to give me a fraction, and now on the top of it, I'm going to type in 1 divided by 8, use the arrow button to move over, and I'm going to subtract the 1. And then on the bottom, 10 minus 3. And now it gives me a decimal, which is totally fine. I could say negative 0.125. But if I want the fraction, which is a little better when you're talking about slope, right? It's a little easier to see exactly how you're moving. There's in the blue section here on my Desmos screen, you see this little picture that looks like a fraction. If you hit that, it will take your decimal and convert it. So you can go back and forth from a decimal to a fraction using that button. So this is also equal to a negative 1/8, or negative 1/8. Okay, so negative 0.125 or negative 1/8. And again, that's arithmetic that you should be able to do by hand, but why? Okay, at this level, we're not really testing that we can add, subtract, multiply, and divide with our, whole numbers, integers, fractions, decimals. We have to be beyond that. So let the calculator do some of that work for you, okay? All right, here's the last one for you to try. Again, feel free to pause if you want to give it a shot. Otherwise, let's see. We have g of x, a quadratic function, and here's going to be our little table. We know from this interval that we have to plug in an x value of 0 and an x value of 5 to see what corresponds with those, what y values or outputs correspond with those x's. So let's find g of 0. G of 0 is going to be a negative 0 squared plus 2. Well, the negative 0 squared part's going to zero out, so we're just going to be left with 2 there. And then let's find h of 5, and be really careful here. We've got a negative, we're going to plug the 5 in, square, and then plus 2. We got to be really careful here to make sure we're following order of operations. We have to square before, we've got to take care of the exponent before we do any multiplication. So the square has to happen before the negative comes into play. Alright, so this is going to make a negative 25 here plus 2, which leaves us with negative 23 for our output. Alright, now we're going to find our slope. So we have y2 minus y1, negative 23 minus 2, and then x2 minus x1, 5 minus 0, so negative 25 divided by positive 5 makes our slope a negative 5, or negative 5 over 1. Alright, and there it is. Not too bad of a lesson. We've got one more for this module, and then it'll be working on the quiz, so hopefully you're progressing right along. But as always, if you're struggling, you need some help, you need some clarifications, just reach out, email, phone call, text, conference, whatever is going to work best for you. Alright guys, take care.